the addition law of probability. In this lesson, we're going to talk about compound events. That's when you have more than one event occurring. So when that happens, suppose there are two events, A and B, in the sample space of the universe U. The following set notation holds. The event that both A and B occur is written A intersection B, where that little upside down U means intersection. So again, this is where A and B overlap. It's called intersection. So A and B both occur. In the event that A or B occurs, so it could A occur, B could occur, or they could both occur, we write that as A union B. There's a little U for union. With that in mind, we have a formula for combined events, which is this one right here. So this formula always works. Probability of A union B is equal to probability of A plus probability of B minus the intersection, which means probability of either A or B or both. So stuff that odds that A or B are both going to happen equals probability of A is going to happen plus probability of B is going to happen minus probability of both A and B happen. So let's put that to work. So again, this one thing that's pretty good about this formula, it always works. You could always put it down. I mean, it might not always help you, but the formula is always true. So let's do with the first one. For the probability of A is 0.6, and the probability of A union B is 0.7, and the probability of A intersection B is 0.3, find the probability of B. So we're just like literally applying the formula. It is in our formula sheet. Written like this. Intersection B. And then we sub in what we have. This is 0.7. This is 0.6. This is probably B is what we're looking for. And then this is 0.3. Just substitute everything in. Probability of A, B is right here. Probability of A is right here. A union B is right here. Do a little math. I add up like terms. I get 0.7 equals 0.3 plus probability of B minus 0.3. So probability of B equals 0.4. So again, all we're doing is putting that equation to work. Okay, what if A and B have nothing in common? In that case, we call A and B are mutually exclusive events. Mutually exclusive, so they don't overlap at all. And that means the intersection of them, as you can see by the Venn diagram here, is 0. So the law becomes for mutually exclusive events, the probability of A union B equals probability of A plus probability of B. And that's it. Because normally, right, if you look at the formula, it's this guy. And honestly, this is the formula I still use. I use the basic formula we just talked about for combined events. I put that down, and then they tell me, and then I read, oh, it's mutually exclusive, and I know that that means the intersection of A and B equals 0. So I go to my formula and I plug in 0 there, which makes my formula probability of A union B equals probability of A plus probability of B. So that's a formula that's also in your formula sheet. Honestly, I don't use that often. I just always use this one, and then if I haven't mentioned it's mutually exclusive, I plug in 0 for the intersection, and you get the exact same result. Okay, let's do a couple more examples. In a class of 30 students, was given a history test. 7 students scored an A, 11 students scored a B. A student is randomly selected. Let A be the event that student recorded an A, and B be the event that records the B. Are A and B mutually exclusive? So they have anything in common? Yes, they are mutually exclusive. They have nothing in common. So it's a little weird. They're mutually exclusive means they have nothing in common. So I'm saying yes, they have nothing in common. Because you can't get an A and a B on a test. It's either an A or a B. You can't have both of them. So A intersection B is 0. Remember, that's what A intersection B means. Oh, you have some students get an A and a B. You can't do that in one test. Find the probability of A. Well, there's 7 students that scored an A, and there's a total of 30 students. So there we go. Probability B. Well, there's 11 students that scored a B, and there's 30 students total. A intersection B. Well, I know it's mutually exclusive, so that's 0. And then the union, A union B. What was the formula for that? Now again, I just tend to use the basic combined formula. And I sub in what we have. We have this is 0, it's because it's mutually exclusive. Probability of B we just found is 11 over 30. Probability of A is 7 over 30. So my answer here is going to be 7 plus 11, 18 over 30. That's my answer. So we have an 18 out of 30% chance of scoring an A or scoring a B. Okay, one last one. I also use that formula, the basic combined equation formula, to solve Venn diagrams. So let's look at this example. In a class of 40 students, so that's my universe, 19 play tennis and 20 play netball. 8 play neither of these sports. As soon as rounding to a different class, determine the probability that the student is blank. So this is a Venn diagram problem. You know, it doesn't say it. I can tell by the fact that there's a total of 40 students. They tell me some breakdown of like each guy plays a certain, or person plays a certain position game. And right here, there's 8 play neither. That tells me, oh, it's probably like a Venn diagram and there's 8 people on the outside. So let me draw a Venn diagram. Draw 2 circles. One plays tennis. One plays netball. One is netball. I know the universe is 40. And then tennis is 19. So that's all of this is 19. And netball is 20. So all of this is 20. I know that neither is 8. So it's like always with Venn diagrams, you're trying to find the middle. And that middle, because that opens up the whole problem for you, is the intersection. Probability A intersection B. So we use our formula. Probability of. Next, let me write down the formula. Then I'll talk about what formula we actually got to use. Just mess that up. Okay, so that's our formula. Now that works for probability. When it's a probability, I should be making fractions. But there's also an equivalent formula that's just the number. The number of A union B equals the number in A plus the number in B minus the number in A intersection B. That's the second one I'm going to use here. So there's the one probability that works, but when there's a probability, I got to put an answer. So you'd be putting A over 40 and B over 40 to make it a fraction. I'm just trying to find the middle here to solve my Venn diagram. So I'm technically going to be using the N version of it, which is just the number of things in them. Works is just the same. So let's plug stuff in. So how many are in A? A is, let's say, tennis. And this is a netball. So in tennis, we have 19. In netball, we have 20. I don't know what the middle is. So I'll put an X there. Now here's the key to the problem. N union, or T union B, N. How many are in tennis or netball? Now the very simple way to find this, it's always the same. You do the universe minus neither. Right? So if you look right here, the neither is 8 and the universe is 40. Well, there's only two things. There's the union here, and then there's the neither. So if I know what the universe is and I know what the neither is, I can figure out what the union is. So I just go 40 minus 8 gets me these 2 circles. So this will be 40 minus 8. And I'm going to get 32 equals 39 minus x. Do a little math. X equals 7. Right? Subtract 37 from both sides. Divide by -1. So I get my center is 7. And once I get that, the whole thing is opened up. So the matter of 7, that makes this side 20 minus 7, which is 13. And it makes this side 19 minus 7, which is 12. So that's one way to solve for a Venn diagram. Is you can use the combined formula to solve it. Where your center here, the intersection is just your X, that's what we're looking for, and then you know what A and B are, and hopefully what the union is. Okay, and once I figure that out, I can solve the rest of the problem. Again, what's the probability? So I'm going to put over 1 over total. I'll put over 40. If they play tennis, well, tennis would be 19 over 40. Does not play netball? Well, netball is right here, and I don't want that, so it'll be 12 and 8, so 20 over 40. Plays at least one sport. So that means you can play one sport or 2 sports. At least one sport is essentially just a union B. I guess in this case, tennis union netball, which is 28 out of 40. plays exactly one of the sports, that's exactly when we only plays tennis or only plays netball. So 12 plus 13 is 25 out of 40. And then right here, plays netball but not tennis. So they play netball, but they don't play tennis. So it's right here, 13 out of 40. There we go. That's the lesson.